Hi guys. Um, I suppose you can hear me. Yeah, even I can hear myself. Good. So my name is Stepan, and today I want to tell you about the hardware wallets for Lightning Network. So I want to start with a question: who is running a mainnet Lightning node? Please raise your hands. Wow, there's a lot of reckless people in the audience. I have to admit, I don't have one. I mean, I have a mainnet app on my phone where I can send a few satoshis to draw a cat on the Satoshi place, and I have a testnet node, but I'm really scared to run a mainnet Lightning node. Because over the years in Bitcoin, we kind of became more and more paranoid, and normally what we do, how we protect our funds, we use crazy multi-signature schemes like 7 of 11, and using the cold storage, air-gapped computers, audio modem cables. We don't trust USB connections because maybe there will be a malware or something. So at all costs, we try to protect our private keys and never put them on the online machine. Lightning, well, it is awesome, it is great. I think that it is a revolution in the ecosystem and it will boost everything. But how we operate the Lightning node? We need to put our funds on the online machine, and also we want to announce to the whole world that, hey guys, I have my funds here, I want to route and collect fees, so, and here is my IP address, so please come and, you know, get it. That is basically the reason why I don't run a mainnet node, because I just don't feel that I will be capable of protecting my own server from that. And I was thinking about that for a few months and thought that it would be really nice to have a hardware wallet for the Lightning. That would operate in such a way that, yeah, you still need to keep it connected to your computer, but at least you can take all your secrets from your server, move that to a separate device that will do only one thing, managing the secrets and nothing else, and run the Lightning nodes in such a way that basically we can decrease the attack surface by a lot, just by using a dedicated device for that. And yeah, that is what I'm gonna talk about. Well, it's not there yet, so we don't have a hardware wallet for Lightning yet, but I know that all the companies working on that, and I think that we can make it happen. But today I want to talk mostly about the architecture, because for Lightning, everything becomes a little bit more complicated, actually. So first, to remind what we need for the hardware wallet for the Bitcoin. Well, there everything is pretty simple. We just need to prepare a transaction, an unsigned transaction, no matter how complicated it is. It can have multiple inputs, outputs, multi-signature, whatever. So we just put together all the data that we need. We pass it to the hardware device. The hardware wallet should be able to parse it to display all the information that we are actually signing, what we're supposed to sign, and then just sign and send back to our online node and broadcast. So basically a very simple iterative process. All the data, sign, kind of prepare, sign, broadcast, nothing else. With receiving Bitcoins, everything is also pretty simple. So here you don't, you just need to make sure that the hardware wallet will be able to control the private key of the corresponding address. So you generate an address on the online host, and then on the hardware wallet, you just check that this address corresponds to your private key, so it was not replaced by someone. With the Lightning, instead of this architecture and instead of transaction as a core thing, we actually have channels. So basically in the Lightning, I need to, unfortunately, I need to spend some time reminding you how the Lightning works, because, well, this defines what we need to pass to the hardware wallet. So in the Lightning, we have, instead of the transaction, we have a channel as a main instance. And basically, how the Lightning node operates, we just open a channel that is one transaction that appears on chain. Then we can update the channel balance many times, 100,000, whatever, and then eventually at some point we need to close the channel, and then we need again to broadcast another transaction on chain. So basically, instead of one on-chain transaction per actual transaction, we can have only 2 transactions per channel and any amount of channel updates there. So how exactly it works is the following. Let's say we want to open the channel to some other node. So we want to put, let's say, 1 Bitcoin into the channel and then start actually sending money back and forth to the whole network. So what we do, we talk to this other node and say, hey guys, so we want to open a channel with you. If you agree, please give me some kind of public key that we should lock the funds to. So he is fine with that because, well, it doesn't cost anything to the for the other node. And we get this public key and prepare the transaction that is 2 of 2 multi-signature. So basically we lock 1 Bitcoin that we want to put into the channel, and we will be able to release it only if both of the parties agree on that. The important thing here is that if we just prepare this 2 of 2 multi-signature transaction and broadcast it right away, and the remote node will disappear, what will happen? Our funds will be forever locked. Right, so before signing and broadcasting this funding transaction, we actually first need to ask the remote node to get the commitment transaction for it. So like, okay, I'm opening the channel with you, I'm putting 1 Bitcoin there, I want to get it back. So let's please sign this transaction where we put 1 Bitcoin to me and 0 Bitcoins to you. Like a fair deal. You didn't do anything, so you don't get any money yet. So then when the other party actually signs this transaction, then we already can get our money back if the other party will disappear. So this is the commitment transaction, and we in return also give the commitment transaction to the other party where we get again 1 Bitcoin and 0 to the other party. And now when we broadcast this transaction and it actually settles on the blockchain, we know that our channel is open and we can start updating these channel values. So how the channel updates work. We have these commitment transactions, so initially 1 Bitcoin to me, 0 Bitcoin to the other party, and then we can update these channel balances and get more and more commitment transactions, and every next pair of commitment transactions has to cancel the previous ones, such that only the last state of the channel can go on chain. This is done by using so-called revocation keys. So basically, if you look at the structure of the transaction that we use here, then the funding transaction is a normal 2 of 2 multisig that is locking everything for 2 public keys, mine and the other node. And then the commitment transaction is actually different for 2 other parties, for 2 parties. So for me, the commitment transaction looks like there are 2 outputs. One output to another node that is a normal pay to public hash. And my output is a little bit tricky. So if I broadcast this commitment transaction, so if I already get it signed from the other party, so I can just sign it and broadcast, what will happen? Before I can use my output, I need to wait for a certain time. And in Lightning right now, it is, I think, 7 days. That will be reduced to 1 day. So normally in the normal operation, it is 1 day. The other option how someone can spend this output is if he knows a certain secret and, well, basically the other party, if it knows the secret, then it can grab all these funds and basically punish me. So the idea here is that if this commitment transaction corresponds to the latest state of the channel, then if I broadcast it, I just need to wait for 1 day and get my funds. But if it is a previous state, then on every channel update, on every new pair of commitment transaction, I give the revocation key to the other party, such that if I broadcast the previous commitment transaction, then I will be punished and I will lose all the money here. So this is this puzzle that is shown here. And finally, there are two ways to close the channel. So one is a mutual close, when I just talk to another guy that's, okay, let's close. I don't want to wait for 1 day. Let's just do a normal 2 of 2 multi-signature transaction that will spend our latest, our Bitcoins according to the latest state of the channel. And we broadcast it to the blockchain and we instantly get our funds back and we can use them. And another option is if one of the parties disappears, then we can just take the last commitment transaction that we have, sign it and broadcast, but then we need to wait for 1 day. So this is roughly how it works. One extra thing is how we actually pay to the remote node that we are not directly connected to. So like if I'm connected to, let's say, Satoshi Place, but I want to pay to Bitrefill, then I can use multi-hop transactions, multi-hop payment to actually reach the final node. So here everything is also pretty simple. We just ask the last node that we are paying to generate a certain secret. Then the hash of the secret basically represents the kind of puzzle. So basically we offer to the node along the route that we will pay you a certain amount. Let's say we want to pay 100 Satoshi to this node, and we are here, and this is the kind of guy in the middle. So we can say, okay, I will pay 101 to you if you give me the hash, if you give me the secret that hashes to this value. Then this guy talks already directly to the final node that I will pay you 101. He gets the hash, he tells the hash, oh, sorry, not the hash. He gets the pre-image, he sends the pre-image to me, so we know now that if something happens, we can all put that in the blockchain, but we don't want to do that. Instead, we just update the channels to the new values. Yeah, I think that's not very clear, but let's keep it like this. Yeah. So going a little bit more into the hardware wallets and what the Lightning nodes, what secrets does it contain. So the idea is, again, that we take all the secrets and move it from the Lightning nodes to the hardware device. The thing is that maybe we don't want to do it with all the secrets, because there are plenty of them. I mean, basically, in every Lightning implementation right now, we use the root secret that then is used to derive multiple secrets that are used for different purposes. For instance, one kind of branch of secrets is the on-chain keys. So basically the private keys for our Bitcoin transactions, for funding and closing transactions and everything like that. And this is basically just a HD hierarchical deterministic wallet that is used for everything. Then there is another kind of path that derives all the secrets for the channel updates. So all these revocation keys, and maybe it is also used for something else, but basically as we use a certain secret for a particular channel. And then there is a third secret that is a node key. This is the kind of our identity to the world. So it is our representation in the network that corresponds to the node ID. So basically when you're connecting to the Lightning node, you are normally saying that, okay, this is the public key and then this is the IP address. So the public key corresponds to this guy, to the node. So obviously, if we want to keep our funds safe, we want to protect these guys and these guys. Yeah, and the nice thing about all this derivation is that they're not connected to each other directly, right? So you can't start from here and then derive the secret on the other branch. So basically there we use hashes and hash key derivation functions. So this means that we maybe want to keep this guy and this guy on the hardware wallet, but about this one, there could be use cases when we don't really care about it. So the node key, for instance, is used for communication, for gossiping, and for broadcasting the information about channel settings and channel balances. So this kind of stuff doesn't really touch our funds. And so maybe we can just keep it on the node itself, and then if we use these secrets to the hardware device, even with the hardware wallet completely disconnected from the node, we will have a kind of Lightning node in a watch-only mode that will still be able to connect to other nodes, not like pay anything or route the payments, but at least talk to them and broadcast that I'm kind of alive, but not quite. Yeah. So about these secrets, and the problem right now is that the hardware wallets that currently exist, they can do only very simple things like this is the transaction, I can sign it, I can display the information about that, and that's it. For Lightning, we need a little bit more of that, and even if you look at the very first part where we open the channel, we can't just make the transaction to a two multi-signature output. We also need to wait for the commitment transaction signed from the other node, right? So before giving the signed transaction, funding transaction to the host, we actually need to make sure that we will be able to redeem these funds afterwards. This is basically what we need to do, but this doesn't require any additional hardware or anything. So it just, instead of one transaction, we need to parse two transactions. With closing the channel, everything is simple. It is basically very similar to what we do right now with Bitcoin. With unilateral close, even easier. But the important thing everywhere here is that the commitment transaction should be stored somewhere and maybe even in unsigned state. So basically the problem is that we use the hardware wallet in the assumption that our host is compromised, like that the hacker already logged in into our Lightning node and can do anything he wants. So the problem here is if he has access to all our commitment transactions from the channel, what he can do, he can just broadcast the old state, and then he will get all the funds. Well, not he will get all the funds, but we will be punished, right? So storing the commitment transaction on the host when it is already signed by both parties is a terrible idea. Instead, what you want to do, you can still store the commitment transactions on the host, and when you want to actually close the channel, then you sign it with the hardware wallet and then broadcast. But the problem here it can be that if someone deletes this commitment transaction, then we are stuck with the forever open channel, and the only way to close it is actually to ask the other node to close it. So I believe that for hardware wallets for Lightning, we need not only current functionality, but we also need additional storage. Because we need to store the latest commitment transaction per channel, at least. And also we need to, well, it can be pretty large because number of channels that we will be opening probably pretty large. So it can be not in the secure storage, but at least SD card. But luckily, both Trezor and Ledger, I think, now has the SD card slot. At least some of them have, and it's not like super hard to add these features. One thing that I want to talk about the node key is actually the invoice. I think this one, yes. So as I said, maybe we want to keep the node key that represents our node in the network away from the hardware wallet, just on the node. The problem here is that this node key is used to generate invoices. So basically, if you are a merchant and you want to provide the servers and accept payments on Lightning, you need to generate invoices. And if you are generating invoices on the server, not on the hardware wallet, then if this node key will leak, then basically an attacker can generate invoices. So the question is, do you want to do that or not? And another important thing that can happen if for the payments, every invoice, every Lightning payment has a hash of the pre-image. And the pre-image is basically a proof of the payment. So these pre-images also should be generated probably on the hardware device. Because if they're generated on your node and your node is hacked, or you don't have a very good random number generator, then you can get the attacker in the middle that will just stop following the HTLC because he already can generate the pre-image for that and get all the money here. I would say that storing the node ID on the host may work if you want to run your Lightning node as a routing node. So basically only collect the fees for the multi-hops. But if you are actually a merchant, then you probably want to store it on the hardware wallet also. And now the pretty hard part that makes hardware wallet for Lightning very complicated is the actual routing. So if we are here, we want to put, let's say, a few Bitcoins in the network such that we can route the payments and collect the fees, but we don't want to lose them. And obviously it is a very sweet honeypot, so everyone wants to get this money. And I am assuming that maybe we will get our server already broken and completely under control from the attacker. If everything is still fine, how the routing happens actually. So this guy wants to transfer some money from from this channel, well, basically transfer some money from here to here. So what we get, he asks our node basically for this HTLC offer. So I didn't say about that yet, right? The offer basically said that if you know the pre-image, if you know the secret, and when it is hashed, it will get this value, then I will pay you a certain amount. And I know that guys afterwards definitely know the secret. So you can ask them, and maybe they will tell you, and so you can collect some fees. So we get this offer. This offer happens actually inside the commitment transaction as another output. Well, technical details maybe not that important. And then we just talk to another guy and offer him the value that is slightly smaller. So we collect some fees, and ideally all this happens without any user interaction at all. So it will be pretty stupid if you need to stay close to your hardware wallet and on every multi-hop opening kind of click confirm, confirm, confirm. Instead, there should be rules in the hardware wallet that allow to do it automatically. So here what we can do, we can from Lightning node just get two transactions to this HTLC offers, the incoming one and outgoing one, check that the fees are actually positive, so we will get some money, and then just go with it. And then ideally, when we get the pre-image back, then we send it further, and eventually all this HTLC magic stuff doesn't even appear on the blockchain. We just end up with updated channel values that are slightly larger in our end. So looks like a pretty robust technique, nothing can go wrong. Now remember that our hardware wallet is connected to the Lightning node, and this means that it doesn't really know anything about the blockchain at all. So it is completely relying on our online host that can be compromised about the blockchain. And what does it mean? Okay, so for opening channel, when we broadcast our funding transaction, we can make sure that it is on the blockchain. We can just ask for the Merkle proof for the transaction that it actually exists in the block, in a certain block. And so we know that the channel was open. Then if the channel is closed or not is a little bit more tricky question. Because if the channel is closed mutually, then obviously another party was talking to us and we were signing this 2-of-2 multi-signature transaction, and eventually we know that, okay, it was probably closed. But there is also another way, right? The other party can just broadcast the latest commitment transaction. Yeah, this is the evil guy. So he just broadcast the commitment transaction and he's already got into our Lightning node. So what happens, he just blocks all the information about the blockchain and doesn't tell us anything about that. This means that if he broadcasts this thing, then his funds will be locked for a certain time. Basically, he waits for 1 day until he actually gets his funds unlocked. And then he starts his tricky, dirty action. So what he does, he tries to route the payment with this HTOC stuff to another node, but we don't know that this channel is already closed. So we already have the closed channel, and we definitely will not be able to broadcast any of these new commitment transactions. And we already can't punish this remote node for this kind of broadcasting the old state, because it was already broadcasted like a day ago, so he already got his money. And what happens in this case, we don't know that the channel is already closed. It was closed unilaterally. The payment kind of goes on. We got the new commitment transactions, but instead of gaining some fees, we actually sent all our money to the remote node and got nothing from here. That's kind of bad. And the simple way to solve this is actually for the hardware wallet to continuously ask for the new blocks. So unfortunately, it adds a little bit complexity to the hardware device in general. Because, well, how can you be sure that you are getting the blocks all the time and that they are not delayed? The only way is to compare to the timestamp in the block. So the blocks in the blockchain have a timestamp. This timestamp is not 100% precise, so it has an error bars of 2 hours, I think, or so. But still, comparing to this 1 day delay, it is pretty small. So this means that you need to get the block headers, compare the time that you're actually getting all the blocks in there. You don't need to parse the whole block. That would be terrible. Like, we try to make this hardware device as simple as possible, but still, we need to parse at least the headers. We need to check that the difficulty is right, the timestamps are right, and also we need to look for the commitment transactions for our channels, if the channels are still open or not. And as soon as we see that, as soon as we see that either the blocks are delayed by more than a few hours, or if the channel actually was unilaterally closed there, then we can detect this kind of attack and actually stop that. I think that I messed up with the sequence of the slides a bit. So in total, comparing to the normal hardware wallets that we have right now, we need some changes. In particular, we need to parse more than just one simple transaction. We actually need to first parse custom scripts, like this HTOC, commitment transactions, multi-signature, obviously, but multi-signature all the hardware wallets can do right now already. And also we need to be able to parse pairs of transactions and make sure that actually it is safe now to broadcast stuff. Obviously parsing Lightning devices, so I think that it may take a while to realize everything, but it's not like super hard, it's not like rocket science. A bit harder is the second part where you need actually some extra functionality of some hardware world. In particular, you need a certain storage to store all this database of the latest state of the channels. And this may be tricky. Well, you still can use the node and encrypt all this stuff with your secret key and use in this way, but it would be nice to have some kind of storage in the You need to generate the pre-images and the revocation keys. And the important thing is that you still need to be able to parse blocks, at least not like verify all the transactions there, but at least verify that the block headers are correct and check that there is no transaction that is closing the channel. So these are the important parts. But nothing looks like super scary, actually. So I think that if Trezor, Ledger, who else do we have? We put some time and effort into making the hardware wallet for Lightning, it will actually work. And ideally, it should be something like a simple USB dongle that you plug into your server or computer, and it secures your key and doesn't expose them into the network and can kind of collect the fees for you. Do I have something else? Basically, I think that's it. So it took a little bit less time than I expected. Sorry about that, but maybe you guys have some questions about this. Yeah.
Please wait a minute. I will give you a microphone because, as you know, we are streaming and also recording. So it will be maybe a problem. Don't have your question recorded. So thank you once again, Stepan. Now we have plenty of time. Thank you. Now we have plenty of discuss this topic a little bit more. So when anybody of you would like to ask, I will give you a microphone and you can say your question. So you're first.
Hello, thank you for that. That was very interesting. Perhaps I missed it. Are you writing your own software for a Lightning implementation, or would this require sort of a software change to existing Lightning implementations?
So it requires certain changes in the existing implementations. Currently, we are working with the C Lightning because basically it is written in C. It is perfect to migrate or steal some parts of the code and move them to the microcontroller. Yeah, we just are pretty much in touch with Christian Decker, who helps us with that. Unfortunately, right now, the existing implementation don't have a complete separation between the kind of secret handling, let's say, process or part of the program and the rest of the things. It is pretty simple to separate the on-chain keys from the Lightning nodes to the separate device, but all the per channel secrets, for instance, they're used all over the places, and yeah, not so easy. And also in the database, and also pre-images in the database. So basically, we need to work together in that sense to separate everything a little bit nicer. Another thing is that even though, for instance, C Lightning has a daemon that's supposed to work as a, well, or be replaced afterwards with a hardware wallet, this HSMD, it's doesn't have all the information that it needs. So for instance, when we are signing the funding transaction, as I said, we need to make sure that we get the commitment transaction, plus we need to make sure that we are the second public key is owned by the other node. So everything like that is not really being passed to the HSMD, only the necessary kind of, well, only the necessary for sign-in information is being sent. So there will be a certain refactor of this and maybe patch. So we don't want to use to write our own implementation because it will take forever. But we also don't want to put a full Lightning node on the hardware device because, well, that will be crazy. So we need to hack everything together somehow, and as soon as it works, maybe we will put a bunch of pull requests for every implementation. But currently we are focusing on C-Lightning. Yep.
Any other questions? Okay, if no, really?
Okay, then we have, I suppose, a 15-minute break.
Yes, thank you very much, Stepan. Once again, please thank Stepan for his speech.
Thanks.
And you can